We now proceed to page 12. And in the example on page 12, we're told that Goldie's Billiards Incorporated is a retailer of billiard supplies. It stands out among billiard suppliers because of the research it does to assure its products are top-notch. One experiment was conducted to measure the speed a cue ball attains when it is struck by various weighted pool cues. The conjecture or guess is that a lighter cue generates faster speeds while breaking the balls at the beginning of a game of pool. Goldie's research generated the data in the columns H and I of the accompanying data sets. I will show you that data in a little bit. Our first goal is to determine if there is a negative correlation or relationship between the weight of the cue ball, that would be one of the variables, and the speed attained by the cue ball, that is another variable. And to see if that relationship exists and to quantify the strength of that relationship, we're going to calculate a correlation coefficient. So why not let's go and see what the data looks like. Here on my screen is the data of interest. We're interested in the two variables, weight and speed. So let's go back to our question. Our goal is to look at the correlation coefficient. And so let's see what that entails. We're going to go to statistics, go to summary stats, go to correlation. And we'd like to find a correlation between weight and speed. And so let's go ahead and compute. We have that the correlation between weight and speed is negative 0.3054216, and that is what I have here. I said from the Minitab output, same as using the StatCrunch output, the sample correlation coefficient R is equal to negative 0.305 and with an associated p-value of 0.052. In order to see the probability value, all we need to do is go back. I'm going to go to options and edit the instructions I put here. And I'd like to see the two-sided p-value. And I can compute again. And I have a different value here. So I have the correlation coefficient R itself, the sample correlation coefficient, and the p-value, which is 0.0522. So back here we are. This is how I got that p-value. Okay, now take note that this p-value could be used to conduct a test of hypothesis. So here we're told to conduct a test of hypothesis to see if there's a negative relationship. Since we are testing if there is a negative relationship, that informs the alternative hypothesis being a negative or left-tailed test. And we're expected to see if there is a negative relationship between weight of the pool cue and the speed attained by the pool cue. We're to use a significance level of 0.025 and a p-value approach, which is why we have the p-value that we found earlier. We're going to be using the p-value approach to decide whether to reject or not to reject the null hypothesis. So to begin our analysis, we ask, what were we given in the question? We need the raw materials or the ingredients in order to cook up the right solution to this question. We have the sample size, and that is the sample size is 41. How did I get this 41? If you go back into StatCrunch, that will be how many rows of data do I have here? And you see that this starts from row 1 as far as row, what row is this? This is row 41. So my sample size n is equal to 41. Then I need my sample correlation coefficient, which is R, that I got to be negative 0.305. Then the level of significance, which is alpha, is equal to 0.025. So now that I have my alternative hypothesis as lesser than 0, I can take my null hypothesis as the other direction or all other values of 0 besides less than 0. And that will be equal to 0 or greater than 0. That will be my null hypothesis, the opposite scenario to the alternative hypothesis here. And so I recall that my level of significance is 0.025. Similar to what we have done in earlier examples, we're using the t distribution with n minus 2 degrees of freedom. And in this case, our n is 41. So 41 minus 2, that gives me 39. And my goal is to find the critical value. So what is the size of the rejection region? Just as a gentle reminder, as it ties to, this is the size of this rejection region is alpha equals 0.025. And I would like to use the T calculator in StatCrunch in order to find the critical value. It is this number. Let me show you how to do that. Go back to StatCrunch, go to Stats, go to Calculators, go to the T distribution calculator. I'm going to go ahead and drag that this way. And my interest here is to supply the degree of freedom. The degree of freedom here is 39. So plug that in here. So you have 39. And I would like to also key in the size of the rejection region in the less than region or lower region. So 0.025, and I want that to definitely be on the left tail, this direction, that direction. So compute. So I have my critical value, which is negative 2.0226909. And that is what I have right here. So remember, the critical value cuts off the lower tail called what? The rejection region. How are we going to use the critical value? Similar to what we have done in previous examples. Let's go to step 3. We need to calculate the test statistic using the formula here. Your R, you recall, is negative 0.305. Bring it in, plug it in here. Then n minus 2, that is simply the degree of freedom you obtained here, which is 39. If you compute this, you get approximately negative 2. So in this case, the test statistic, you have negative 2. If you check, where does this negative 2, where does it fall in this picture? Does it fall in the rejection region, or does it not fall in the green non-rejection region? You might observe that this number comes before negative 2. So it should be a number somewhere here. So this does not fall in the rejection region. So we already know what our final decision will be if we go by the test statistic relative to the critical value. So as it stands then, we know that we're not going to reject the null hypothesis because the test statistic value does not fall in the rejection region, which is to the left of negative 2.02269. But the question says we should use the p-value approach. How does that mean? Remember we got the p-value earlier to be 0.052. The p-value approach advocates that we must reject the null hypothesis if the p-value, if it is lesser than alpha. Let's check. In this scenario, is the p-value actually lesser than alpha? I would argue no. I see 0 and I see 0. I see 0, I see 0 again. I see 5 before 2. This means that our p-value is greater than our alpha. Well, since the p-value is greater than alpha, that leads us to the same conclusion we would have reached if we use the test statistic versus the critical value approach to draw our final conclusion. So, based on these two facts, the fact that the negative 2 is lesser than the critical value, and also that the p-value is greater than alpha, we follow the decision to fail to reject the null hypothesis. Thus, we have insufficient evidence for the alternative hypothesis that we wanted to test, and we conclude at alpha equals 0.025 level of significance that we do not have sufficient evidence to conclude on a negative relationship between weight and speed. So with that said, that brings us to the end of question on page 12 of your notes. Let's proceed then to page 13. So this was done in reverse. So quickly, let me go to page 13. On page 13, um, we want to advance into simple linear correlation analysis. Remember, as far as correlation analysis is concerned, our goal is to quantify the strength of the relationship between two variables. In this case, we would like to look at simple linear regression analysis. You see, if I saw two people walking side by side, and I asked, how strong is the relationship between those two people? Correlation would be the one to answer the question, and it would give me a value between -1 and +1, quantifying the strength of the linear relationship between those two people. Otherwise, if we are talking about what is the type of relationship between two people, are they cousins, are they friends, are they professor and student, what is the type of relationship between them? Regression would be the one to answer that question by explaining the nature of the relationship between two variables. To motivate our understanding of regression analysis, let's consider this example. We're told that the data shown below indicates the average tuition in dollars over a 6-year period for private and public colleges in a region. So you have the private college, you have the public college, and so we have the data values here. The initial question here is to conduct a simple linear regression analysis of this data in the average tuition, in which average tuition for private colleges is predicted by average public college tuition. We're to test that the significance of the model using alpha equals 0.10. So here is what you do. To conduct a simple linear regression analysis, step 1, you need to map out in your data columns where we want to look at the relationship between average tuition for private colleges, and the data for that is given here. I'm highlighting it in green, and the data for public college tuition, I'm highlighting in tan or yellow, whatever you want to call it. And so in particular here, we want to look at the relationship between these two variables. Here is what you do. Step 1, you need to ask yourself who is going to be y and who is going to be your x variable. Y is the dependent variable. I would argue that the way private colleges set their tuition is almost semi-dependent on how public institutions that are running parallel to them might also set up public their tuition. So private here, we'll adopt that as our y, and so that leaves public to be x. So step 1 would be to build a scatter plot using Minitab or any other technology. I'm setting my y to be the response variable or private college tuition, and x would be my independent or predictor variable, which would be public college tuition in this context. So let's go into StatCrunch and draw a scatter plot of this data. So here we are in StatCrunch. I'm going to close out of this, go to graph, go to scatter plot, and we want to make sure that our y variable is private. That depends on the public institutions set values for tuition. So in this case, my polynomial order, 1 as usual, leave it as the default best fit and click on compute. And so here I have the regression, here I have the line. So this is the linear model. And from what I see here, we observe a strong linear and positive relationship between private and public college tuition. I may also include that from the picture, I don't see any particularly stray point from this line of best fit. So that is what including too if you want. And now the next step is to fit a simple linear regression model, that is an equation of this line. Do you remember your y equals mx plus b? So let me move my cursor up to this. You will observe that StatCrunch reports immediately the predicted y here. So this is y equals you see the 3023.4857. That is your B in y equals mx plus b. And your m is usually the number beside x, because you remember we used to say y equals mx. So our m here will be 2.9693049. So that is the slope of this regression line. Okay, so as it stands then, we can say that private is related to public by this what? By this equation. So this is similar to your y equals mx plus b, where your intercept is a standalone number and your public, remember, that was public was your x, so that is x here, and then the slope here is m. How do we interpret this given parameters or this given estimates of the parameters of the regression model? First of all, what you quickly observe, the first one that is always of very, very meaningful implication is the slope. And here it is 2.969. How do we interpret it? We say that when public tuition, the x variable, when it goes up by 1 unit, so that will be $1, we expect on average that private, being the response variable, private college tuition, being the response variable, will respond by also increasing. Why is it also going to increase? That is because the slope is a positive number. So as public college tuition increases, we expect private college tuition to also increase on average. By how much? By this much, by the value or the magnitude of the slope. So in this case, we expect private tuition also to go up because the slope is positive by about $2.97. So take note, if public goes up by $1,000, that means private will go up by 2.969 times $1,000. So that is very important to note. That is the explanation of the slope of the regression line. And then you have the y-intercept. For how do we interpret the y-intercept? That will be you set x to 0 or public college tuition to 0. So if public tuition was $0 or free, we expect on average that private colleges would charge on average $3,023 on average based on this data that we have analyzed. Then the next part of the question said we should test the significance of this regression model using an alpha equals 0.10. So to test the statistical significance of the regression slope, this is what you do. You see this slope right here, if it was 0 in this case, take note that that 0 would multiply the public, and that would mean that private would just be a constant value, independent of public, because all of this piece will go away if the slope was 0. So anytime the slope is 0, it means that there is no connection or correlation between private and public tuition. So if we're to test the significance of a model, it is equivalent to testing that the slope of this linear model is equal to 0 versus it is not equal to 0. And we're going to conduct that test at alpha equals 0.10 level of significance. Now, the critical value in this case is obtained using the t-distribution with n minus 2 degrees of freedom. So what is our n here? How many data values do we have? How many points? How many pairs of points do we have? 1, 2, 3, 4, 5, 6. So you have 6 minus 2, which is 4. And so this is going to be a two-tailed test looking at the alternative hypothesis. So two-tailed test here. And so how do we find the 2.1318? This is what you do. You go to your StatCrunch. Let me close out of this and go to calculators. I'm going to the T calculator, and let's look here. And what's our degree of freedom? Going back here, the degree of freedom is 4, and the total size of your rejection region is 0.10 or 10%. So on either side, that means you're going to have 5% here, 5% here, for a total of alpha, which is 10%. So 5% here, 5% here. So going back to StatCrunch, I'm going to key in my degree of freedom, which is 4. I'm going to key in the size of one of the tails, which is 0.05, 0.05. And just to remind you, degree of freedom is 4, 0.05. I can choose either greater than or lesser than. So here we go. And I'm going to click on compute. If I choose the less than, it shows me the cutoff for the lower tail, which is negative 2.1318. So let's go back here. You also have that positive value here. So with that said, we have the cutoff value here. So you have the critical value here. And then in order to find the test statistic, we can use Minitab or StatCrunch. In this illustration, I'm going to use StatCrunch to complete the same work here. So to show you how to get the test statistic in StatCrunch, let me show you what to do. You go into StatCrunch and you go to Statistics, go to Regression, Simple Linear Regression, click on Simple Linear. We're going to choose the Y variable. We want to see if private public tuition depends on the public tuition. Then make sure you click on Perform Hypothesis Testing. Make sure you click on this. You see that this is set to 0 versus not set to 0. And we are interested in performing hypothesis testing on the slope. This is equal to 0 versus not equal to 0. Take note that I wrote this earlier in our notes here. Equal to slope equal to 0 versus slope not equal to 0. So going back here, I can go ahead and click on compute. And look at the wonderful output here. So I have it reports the dependent variable, the independent variable. It reports the regression line, which is 3023.4853, which is what we had earlier here, you recall? And then it also reports the correlation coefficient and the coefficient of determination. In particular, what I'm testing is concerning the slope. And so for the slope, in this case, you go back here and you look at where you have the slope and you look for the test statistic corresponding to the slope right here. This is the slope again, and I'm interested in the test statistic corresponding to it. So that is 13.36. Take that 13.36 here. Where does 13.36 fall? 13.36 is definitely a value bigger than positive 2.13. So it falls in the rejection region. Since it falls in the rejection region, it means it will cause us to reject the null hypothesis. So we are rejecting this guy, which is saying that the slope is 0 versus, and that means we're going in favor of the alternative hypothesis, which is saying that the overall slope of the model is significantly different from 0. And so we can make that conclusion at alpha equals 0.10 level of significance. So with that done, we have come to the end of the question on page 13 of your notes.